Hello, my name is Pacifica Waisenga from Ines Ruhengeri Department of Biomedical Laboratory Science in Year 3. I'm here to present to you the 5 questions which start from questions number 33 up to 37. So without further delaying, let's kick off. The first question, which is question number 33, says that what is the principle of precipitation reactions in immunology? So these precipitation reactions occur when soluble antigens bind to specific antibodies and forming a soluble antigen-antibody complex. Uh, when the antigens and antibodies are in a correct proportion, they form a lattice-like structure that precipitates out of the solution. And there is a zone of equivalence, which is the point where the antigen and antibody concentrations are optimal for precipitation. Let's move on to the next question, which says that how is the radioimmunodiffusion test performed? Firstly, this radioimmunodiffusion quantifies specific proteins in a sample using antigen-antibody precipitation in a gel. There is a steps of this radioimmunodiffusion. Let's look on the first step, which is the gel preparation. And the gel used here is agarose gel and is mixed with an antibodies specific to the antigen binding being measured. The next step is sample application, where the wells are punched into the gel and the sample containing antigen is added. The next step is diffusion, and this diffusion, the antigen diffuses radially from the well, forming a precipitating ring where it interacts with the antibodies, and this ring is going to be used in the next step, which is measurement. In the measurement step, the diameter of the ring is going to correlate with the antigen concentration and is compared to a standard curve. Let's look on the next question, which says that what is the principle of ELISA technique? As we know, ELISA stands for enzyme-linked immunosorbent assay, and this ELISA detects and quantifies antigens or antibodies using enzyme conjugated antibodies and calorimetric reaction. The principle of this ELISA based on antigen antibody binding, where the specific antigen or antibodies bind to its target, followed by the enzyme linked to a detection antibody which characterizes the reaction, and the enzyme reacts with a substrate to produce a measurable signal, which may be a color, which is going to be the color change or fluorescence. And after this signal is produced, it is going to be quantified, where the intensity of the signal is going to be proportional to the antigen or antibody concentration. Let's move on to the next question, which says that how is this sandwich ELISA different from indirect ELISA? Uh, Firstly, to differentiate this sandwich ELISA from indirect ELISA, we are going to focus on those features. Let's start on the coating, where the plate, or sometimes they use a word well, microtiter well, is going to be coated with a captured antibodies, while for indirect ELISA, the plate is going to be coated with an antigen. The plate or a well for indirect ELISA is going to be coated with an antigen. For primary binding on sandwich ELISA, the antigen is the one which is going to bind primarily, while for indirect, the primary binding is going to be the primary antibody. The primary use of sandwich ELISA is to detect and quantify the antigens, while for indirect ELISA, its primary use is for detection and quantification of antibodies. On detection, sandwich ELISA uses the pair of antibodies specific to different epitopes of target antigen, while for indirect, ELISA uses primary antibodies, which is specific to the antigen which is pre-coated on the well, and use the secondary antibodies, which is also specific to that primary antibody. Let's look on this structure. As you see, the indirect, the word is coated with an antigen followed by primary antibody and secondary antibody. While for sandwich, the word is coated with an antigen. The word is coated with an antibody followed by the primary binding of antigen, followed by another antibodies which may be coated with an enzyme or followed by another secondary antibody which may be coated with an enzyme. But sandwich, when it's coated with primary antibody, when the primary antibody float is coated with an enzyme, is called uh, direct sandwich ELISA. When there is a second antibodies applied, which is coated with an enzyme, it is going to be indirect sandwich ELISA. Let's look on the last question, which says that what are the applications of ELISA in clinical practices? Firstly, ELISA is widely used in diagnostics, research, and therapeutic monitoring. Let's look on the applications of this enzyme-linked immunosorbent assay. The first application is infectious disease diagnosis, where this ELISA is going to detect antigens or antibodies for disease like HIV, hepatitis, and COVID-19. The next application is hormone measurements, where this ELISA is going to monitor the hormone level. For example, TSH and HCG, where TSH stands for thyroid stimulating hormone and HCG stands for human choreogonadotropic hormone. The next application is autoimmune disease detection. This ELISA is going to quantify the autoantibodies. As we know, these autoimmune disease they are caused by autoantibodies which mistakenly attack the immune system. And those autoantibodies, they are going to be quantified by this ELISA. Among those autoantibodies, for example, there are rheumatoid factors, ANA, and so on. Let's look on the next application, which is allergy testing. This ELISA is going to be used in measurements or measuring allergen-specific IgE antibodies. The next application is for cancer markers, where this ELISA is going to quantify tumor markers, for example, like PSA and CA125. The next application, this ELISA is going to be used in therapeutic drug monitoring, where ELISA is going to track drug levels, for example, track therapeutic antibodies. And the last application is going to be ELISA is going to be used in the research, where it is used in measuring cytokines, growth factors, and the other biomarkers. So thank you very much for your kind attention. I hope you have enjoyed the presentation. Thank you very much. May God bless you. Bye bye.